Does your child's homework look like a foreign language to you, a language you don't understand? If so, take a look at this video. We're going to do 26 times 44. 26 times 44. So when I look at this 26 times 44, if your child starts with a whiteboard or paper and starts just writing down 26 plus 26 plus 26 plus 26 plus 26 plus 26, and they start writing this down, and you begin to think, oh my gosh, are they going to do it 44 times? Again, I would challenge you to let them go through that process. Although it might not be the most efficient strategy, it is helping them to understand how does multiplication work. But at some point, hopefully, again, they're going to realize, I don't want to do that. That's not the math I want to do. I want to do something different. And when you look at their notes to help them, or when you look at their book, or when you look at online to help them, you might begin to see some boxes and some rectangles instead of a standard algorithm. And if that's what you see, that's probably why you're here, actually, to begin to understand what is this area model we keep seeing about. So I'm going to show a model of what we have here. This is a rectangle I can draw to represent 26 times 44. So here's 26 times 44. And we can think about this. If it were a rectangle, could I find the area inside? What I really could do, and what we're recommending students do, is we're recommending that they take 26 and decompose it, or break it up into 20 and into 6. And take 44 and decompose it into 40 and into 4. Now, the reason we would do that is to help us understand, okay, can I break this up with easier numbers that I'm actually familiar with? So if I break 26 up into 20 and 6, and I break 40 up into 40 and 4, I can then think, okay, so when I'm looking at this, what is 20 times 40? Well, I know 2 times 4 is 8, so 20 times 40 is 800. And I think, okay, what's 20 times 4? Well, that's 80. What's 40 times 6? Well, that's 240. And what's 6 times 4? That's 24. So we're using what students are familiar with. We're using our tens tables, our tens facts. We're using some learned information they already have to break a larger multiplication problem up into smaller chunks, into partial products. So then what we're going to do is we're going to add those partial products together. So when I'm looking here, I can begin to see that 800 plus 240 plus 80 plus 24 is 1,144 using partial products. So then some of you might ask, well, can't we just use the standard algorithm? Can't we just use the way that we learned it in our time? And yes, we absolutely can. Again, we're going to recommend that you don't just start there, though, because this is a very conceptual, visual way of understanding why that works. The multiplication algorithm that you and I learned didn't really talk about why. We just said do this 100 times and finally it'll begin to make sense. So let's take a look and see what would happen if we did the standard algorithm. 26 times 44. So 4 times 6 is 24. Carry the 2. That's kind of a weird thing. What does carry mean? Again, sometimes we say these rules, we don't really know what they mean. 4 times 2 is 8, plus 2 is 10. I don't know why I'm doing that, but my teacher told me to do that. So then we do this like this weird magic zero thing. I don't know why I'm doing the magic zero. Looking at this, I do now as a teacher, but thinking through here, that might be something I don't know why, but we put that 0 there as a placeholder. We'll get into that in a minute. But then I do 4 times 6 is 24. Again, carry the 2. 4 times 2 is 8, plus 2 more is 10. Again, this is a rule that we learned that our teachers may have taught us, but many of us have no idea why it actually works. And I don't mean that to be judgmental. I mean that to be, we just learned it, our teacher said do it, so we did it, and we listened. Now, we're trying to actually build thinkers these days in our math classrooms. We're trying to build students' ability to actually process and make sense. Does it make sense? When I'm looking at this standard algorithm, nothing is really making sense. I'm just doing what I'm told. What I'm trying to do is build some sense making. So if I'm trying to build sense making, I might ask a student, this 104, I see 104 here, or this 1040, but this 104, what does the 104 mean? Where did that number come from? And maybe I push back over to here, do I see 104 anywhere up here in this model? And I very often ask children this question is, I see 104 here, what does that mean up in the model? And I give them a minute to think about it. And if you're thinking about it right now, you might notice that 80 plus 24 is in fact 104. And when I'm looking at this, 80 and 24 is 104. Well, where did I get 104? I said 4 times 6 and 4 times 20. Actually, it's 4 times 6 and 4 times 20. 80 and 24 is in fact 104. And in fact, as I'm saying that, I'm beginning to see, remember, I carried that 2. I carried the 2 because I just brought the 2 up. So it was 4, 24. That I have 2 10s. I'm kind of holding on to those until later. We'll bring in those 2 10s later. We get 104 here. There's a whole lot more we can dive into this, but as I'm looking at this, I'm beginning to make sense of what does it actually mean when I'm multiplying versus what's a rule that I memorized.